All right, 46, determine the intervals of the domain over which the function is continuous. And we've been looking now at continuity in questions 44 and 45 and now 46. And we know that continuity, or to be continuous, means that we can graph our function without having to lift up our pen or pencil from the paper. And that's clearly not the case here with 46, right? We have a vertical asymptote that's been identified for us at x equals 3. And what that asymptote, that vertical asymptote, does is it breaks our graph up into a left-hand side and a right-hand side. So if we go ahead and try to graph, or trace rather, the left-hand side here, we can see that we're skating across the x-axis and we're going to swing up and we're going to get infinitely close to that vertical asymptote, never quite touching it though. So here's that left-hand side, but when we get here, we've got to pick up our pencil, move it back down, set it down, and then continue graphing again. And so clearly there is a break in this graph, right? We have to physically lift up our pen or pencil. And that happens when x equals 3. And that's why they've identified this, this point for us, 3, 0, so that we can know what the x value is of this vertical asymptote. All right, so this graph is continuous from negative infinity. As the x value gets larger and larger and larger, it's going to get infinitely close to x equals 3, to that vertical asymptote in both locations here, but does not actually ever exist at x equals 3. So there's a continuity issue here, discontinuity. It picks back up again at 3, and the x value will continue to get larger and larger and larger out towards positive infinity. So we can say that the domain over which this function is continuous is from negative infinity to positive 3. And again, we're not including positive 3. We pick back up, so we use a union symbol. We pick back up again at 3, and then we exist out towards positive infinity. So this graph, this function exists everywhere except when the x value is 3, because at 3 we have a vertical asymptote there.